workshop, because we will be starting from the very beginning, like how to make circuits with resistors, batteries, diodes, and all those stuff. It's not very complex. So because it's just a starting, and the main objective was to help you with your electronics 3 assignment. I think that's related to op-amps. So yeah, so that's basically our main objective, and I hope this workshop can help you eventually. So let's begin. First, we have the workshop highlights. I'd like to just have a briefing. We have an introduction to the main interface, because each software has a different interface, be it MS Word, PSpice, Proteus, or anything. They have a different interface. So once we open it, it's something very new when we're doing it for the first time. So we'll have an introduction to the interface, the main window of Multisim, and we'll compare it with PSpice, the other software that we usually use. Our university uses, though it's very old, but usually it's used in most of the universities around the world. So we'll have a comparison with PSpice and why, if Multisim is better or PSpice is better, which one. Then we'll have a short discussion on the circuit analysis. That's basically Ohm's law and Kirchhoff voltage law, current law, all those things, because we need those knowledge before we can work with circuits and see how they behave and all. Then we'll have simulations that's actually working with Multisim. Then basically we'll have different components. So that's how we'll go, and at the end we will have active components. That's basically, what shall I say, where your op-amp falls, and we will then discuss the op-amp behaviors and everything that should relate to your assignment. So that's basically the window we have for Multisim 11, I guess. Yeah, that's 11. So when you open, this is the window you get. That's, I think, very similar to the one you get in PSpice. There's a screen for something. We have menu bars and icons and everything, which we'll explain as we go on. This sentence is actually from their website. So that's how they describe Multisim. Like, it's a schematic capture and simulation program designed for schematic entry and fitting to downstate steps, simulation, microcontroller, co-simulation. So basically I have highlighted schematic, simulation, fitting to downstate steps, because these are the main features of the software. With schematic, the circuit designs we see, the power source, resistors, active components, passive components, inductors, however you want to describe them. So that's the schematic, the circuit diagram or design, as we say. Then that's the thing we do in Multisim. We make the design. After that comes simulation. Simulation is when you have a circuit, you want to apply voltage or current to it, and you see how it behaves. You want to see how it behaves when we apply different kind of voltage or current or anything. That's a behavior. We want to see how a circuit behaves. We have an input and we have an output. So that's basically a simulation. We run the circuit. We see how it would work if we connect a real battery to real resistors. That's what we usually do in this type of programs. That's a simulation. And the third one is very interesting here. That's feeding to downstate steps, such as PCB layout. That I would say is, once you have a design, say there are like 100 resistors, 30 capacitors, 50 inductors, you have to implement it on a real circuit. So it's not going to look the same as your breadboards. There is a PCB layout. I think I can show something. So that's the PCB layout. Let me see if I can show something for PCB. So as you can see, that's the PCB layout. Okay, that's how it looks actually. Those are the dots. You put your resistors, in the things you connect with soldering and everything, and that's how a PCB thing looks like. I think I go back. It's PCB board. Okay, I guess, yeah. So this is actually a final PCB board with all the components. You can see, the circular ones are actually like cylinders. They're capacitors. Then we have inductors and resistors all throughout. So this is basically how a real-life circuit looks like. So when you have a design in Multisim, like you have many resistors and it's a very complex circuit, you can convert that circuit into this kind of design. And then you can just print it on the PCB board and everything. Because usually what we do is we draw a rectangular circuit and it's very rough drawing. But when we are trying to implement the circuit in real circuit boards, this is what we actually do. We need to do wiring and everything. As you can see, the light greens are actually the connecting wires. As you can see, it's sometimes it's diagonal, it's straight, but it's never round or something. So you need to accommodate for all these things. And it should be, parallel to each other. There is a particular distance. So when you have a design in Multisim, what you can do is you can auto-generate a design. When you have, say, resistors and everything, you just there are some tools. You just click on it, and Multisim will automatically suggest you a design which you can really implement. But if it cannot, then of course you can bring changes and as you wish. But Multisim will make it easier for you to bring this kind of designs. So that's what I think downstage stepping or something. Yeah, feeding to downstage steps. So that's a very good feature of Multisim. And they have another software, I think it's Altiboard or something. And you can also have microcontrollers and you can code them with Multisim. Next is the advantages. Actually, for advantages, we have to know what other options we have. Before we go to advantages, we know what other options we have for circuit simulations, or how you want to describe. The first one that I've experienced was that there is no grounding problems. Like this node is floating, that node is floating. When we work with PSPice, I think, okay, I don't have a start button. It's like this. Okay, so one, I think student. I think it's capture. Run as administrator. Let's open PSPice first and then we can compare. So basically this is PSPice. We have a new file. This example or something, like analog. Okay, we have to specify a path. Okay. Okay. User. Okay. Create a blank project. Okay, so that's basically how the PSPice looks like. And here, so you don't need to run it as an administrator. You just click on Multisim. It should open. Okay, so as I was discussing the advantages, first is there is no grounding problem. When you have PSPice, sometimes the ground is not connected, they have a floating or the wires are not, after you delete a wire and reconnect the wires, there is some gaps and stuff. So with Multisim, these problems are no more there. You can copy and modify circuit easily. I'll explain that later on. You can have real-time oscilloscope. That is, in Multisim, there are instruments like oscilloscope. You can place them with your circuit, you can run them. And you can see the display as you see in a real oscilloscope. So PSPice don't have those things. I think it's open. Yeah. So as you can see, okay. So the right one is PSPice and the left one is Multisim. So you can see it's very much similar. They have this dots there over the page, which we don't see in MS Word or something. That's a specialty of, I think, the simulation software. The other things are, you can see these are toolbars here, and here also they have toolbars, this. It's actually kind of very similar interface because both are simulation software. So this is a PSPice. I was discussing the advantages. So One is real-time oscilloscope. That's I said you can place an oscilloscope and you can see the display in real time. The fourth one is components rename automatically when copied. This is something I find very convenient, because when in PSpice, say you have you place something for, you have resistor, I think, yes, this resistor. So you have a resistor here. They would name it R1. Okay, they would name it R1. I think you can see it here. You can press Control. Okay, it's there. It's R1. Okay. So when you try to copy it, say copy and you paste, it's still R1. Okay, so when it's R1 and R1, then there's a problem, because when you try to simulate it, they'll say there are two, similarly named parts and they can't simulate. But in multisim, what I saw was when you have, say, a diode. Okay, no, let's just have a resistor. I think it's in basic, yeah, resistor. Yeah. So when you have a resistor here, it's named R1. So when you copy it, say there is copy, and when you paste it, it's R2. It's automatically renamed. It increases. So you don't need to worry about renaming the things, because sometimes you don't want to go to parts and import another resistor. You just want to copy this resistor and use it in your circuits. So this is a very convenient thing in multisim. In PSpice, you can't do that, and then it will cause problems. After that, there's a huge library of components, like with real-life product codes and specifications that you'll understand when you go to PSpice. Say you try to place something apart. So this is R. I wrote resistor. So they have only one resistor, and that's 1K. That's the only thing they have. They have another, maybe this is just analog, that's R with a question mark, and this R var, but it's a different, it's a variable resistor.